Hi, George. I think we got it. Yay!
I think we did.
Ast Training presentation. You see that my daughter did all the graphics and stuff and made the slides for me.
Oh,
Because
nice.
It's complicated, of course. She's very talented. So I got
That's a nice rope tornado right there.
Yeah, we got quite a few things going on there,
Mm-hmm. Quite a debris ball on that thing.
All right. So, what we're going to talk about today, I'm going to just go briefly about, like, getting set up, ready to chase.
Yeah.
But mainly focuses on tornado images. That's what I'm going to try to focus on. I don't know if you have this app. The reason I put this on, I try to make it easy where I can, if I don't want to spend a lot of time trying to figure out where I'm going, I try to make it where it's quick.
Yeah.
And I really only use this too much because I can get the severe lookout, for the next few days, and it's up to date. So that's what we do. We get that out, and you see what I can pull up real quick.
Yeah. The SPC.
Okay. Yeah, but you got Wednesday, Thursday, Friday.
Yeah.
And figure out, if you don't see anything, don't have to worry about it, But that way I get plenty of notice.
Yeah. Yeah, the other day was the first time I ever checked the SPC on my own,
Okay.
But, of course, the models looked nice, but everything just fell apart on Thursday.
Yeah, and models are very confusing.
Yeah.
They can be very confusing. There's so much information out there.
Yeah, just that nice slight risk area that we were in, and all of a sudden, nope,
No.
it just fell apart.
And it can happen. Now look at this day. You know what I mean? I'm getting off, now we have a hot week going here.
Yeah, that's a hot week.
Yeah, and I'm sure well, I think I got it on the next frame here. Yeah, you know what all the colors stand for, how to...
Yeah, moderate risk.
Right.
Enhanced risk, slight, and marginal.
Yeah. Like I said, when you see it enhance,
Yeah.
I'm hot, ready to go. I chase slight, but I'm not going to go like hundreds and hundreds of miles for a slight chance,
Yeah, but if there's an enhanced risk, we're crossing state lines if there's an enhanced risk.
Moderate, like right now today,
Yeah.
they're having a hot down by 101's house. Right
Yeah,
now.
if they're,
He's definitely in the moderate zone.
Now, if there's a slight risk in eastern Iowa, I'd probably go for that.
Oh yeah, no, I do. I was going to tell you. There's one of the, you can't always go, like you said, just what happened the other day.
Yeah.
Over the summer, there's an enhanced risk. Indiana, South Indiana, Illinois, Kentucky in that area. Well, I chased it, right? And there was only a slight risk in Iowa, which I usually would go sometimes,
Yeah. Well,
And sure enough, it was nothing. I got nothing. The only time there was tornadoes, it was almost in Ohio before it finally was producing. And in Wisconsin or in Iowa that day,
well,
it was a major. It must have been like 8 or 9 tornadoes. Yeah. So you can't. It just.
I always make the joke: Iowa or bust.
Yeah. So okay, we know that, and then this is other people use
Pivotal.
College of DuPage. The only reason I don't use it because it takes longer to get to, and I just use this because I'm more familiar with it. I got an app. I click on it, boom, I'm there.
Okay.
Hit models, boom. Instead of having to search, and plus if you're out in the field too, you don't have to. I just try to do things the quick way, and plus I'm used to. I got very used to pivotal weather. Do you use pivotal weather?
No, I've never used it.
Well, I'll show you remind me before you leave, where you get the app and start it, because that's the one I use.
Okay, yeah.
I'll show you how to. Okay, and then now we got up here. They're just showing you. This is like when you open it up on the model when you touch models. And of course it goes to GFS right away, Global Forecasting System. But the next lesson is going to teach you a little bit more of all the things, but you should I'll show you how to do that and get familiar with it. Because, you can get some shortcuts to try to make it simple on you instead of sometimes there's just too much information.
Yeah.
All right. Now right here we're just checking one. Right now we're at ground level wind, AGL at ground level.
Yeah.
We're checking the wind speed, and of course you can't see that graph down. You can see there at the bottom, the purple.
Yeah.
It's showing almost, what is it? It's getting 25 knots and stuff. You know, which is over 20 miles per hour. So you can kind of figure out. See the barbs?
Yeah.
You know what the wind barbs are and stuff.
It's showing the which way the direction is.
Correct. You can see what's happening.
Yeah, it's kind of curling back in.
Right. So yeah, we see Dorothy down at the bottom there.
Yeah.
Right? Let me in. I can't read the blue there. Can you read that real quick? You can't. Oh, I'm sorry.
Moisture, instability, lifting. These conditions are needed to produce thunderstorm by applying wind shear with these conditions. The result is a severe thunderstorm.
Okay. So that's what that's on there. I was trying to get where Tony can hear what we're looking at there because I can't. The blue is somehow blurry on the TV and I can't see it.
Yeah, if it was yellow, it'd be a little easier to read.
Okay.
Significant tornado risk.
Right. This is what I use a lot.
Mm-hmm.
Significant. Remember that one. I'll show you where that's at. The significant tornado risk. STP is what they call it.
Yeah.
And that's also, they have like an STP on the skew.
Yeah.
Kind of like, it's just a moving scale. I'll show you. But that's something that's important at what I use.
Yeah.
Because, you know, when you start seeing that blue there, you know, if conditions are right.
That's going to be the hot zone.
To form a tornado. But now you have to have everything come together right at that area to happen. And just like the other day, it didn't involve. You know, we were in we had a spot like that in Ottawa, but it didn't involve because all the ingredients didn't come in together like it should. So it's just giving you an idea if something's going to happen, that's where it's going to happen. Did you see the cow?
Yeah.
Did you see that?
Same cow.
Yeah. All right, dew point graph. That's what now I'm checking. You know, I'm checking models, right? Mm-hmm. Now we're checking the dew points. You know, and what do we got there? That looks like we're getting 60 dew points right there. The dark or the blue.
Yeah.
So that's important because we want to know the ingredients are there.
Yeah.
So what I look for is 55 plus.
Yeah.
55 is just marginal. When you start getting 60s, then it starts getting. That's good. That's saturation, 60 plus. But 55, I'd start paying attention to. You know, I'm planning the day. This is like maybe a day out or two, trying to figure out where the area is going to be, where I can figure out where my target area is.
Yeah.
All right. Now, helicity. You know what helicity is? I think it does. Okay. Combination of CAPE and SRH. Two types. 0.1, that's kilometer, or I guess kilometer. 0.3. You know what the km is on that? I forgot if that's kilometers.
Yeah.
That's what it is. Not kilometer, kilometers. 2.5 favorable for tornadoes.
Yeah.
Okay, and that's what's happening today, by the way. We have a lot of helicity.
Yeah.
That means spin in the atmosphere.
Yeah.
Things can spin, and that's what we look for. I'm setting up a target area.
Yeah.
You know, just this is looking into the future. Okay, now here's our bulk shear. That's another word we'll be getting familiar with, this bulk shear. Look at that graph, and again, on the bottom left right here, that's a hodograph. And that's on a skew T-chart, and it's a little confusing to read, but once you get used to it, I kind of look for a horseshoe. Yeah, you see with that red line? Follow the red line and then how it starts curving?
Yeah.
That's showing your shear.
Okay.
Okay, it's actually giving you what direction the wind's coming from and how fast it's going at what height.
Yeah.
It also can tell you storm motion too.
Yeah.
Once you get used to it. If it's a right mover, a left mover, is it moving northeast, northwest, or...
Okay.
Yeah, but you can see the barbs. They're giving us the bulk shear where we can see where that real red is. That means the wind speed's really strong over in that area. Storm helicity graph. That's another one. just leave it on for a few minutes because you can read that. You see how the SR, this is what gets me. See at the bottom,
Yeah,
the SRH. A lot of this
it's a
is bigger
calculation.
It's calculations and algebra. I guess you need to know, right?
Yeah, geometry.
Yeah, is that what it? Because I did not have.
I think that's
algebra.
geometry.
You're algebra, or what does that? What would you explain at the bottom? The SRH, like what is that?
That's like calculus.
That's calculus.
That's what it would be. The word's calculus. Okay.
I never took calculus.
No, I never.
But like I said, there's a lot to figure. That's what they do to figure all this. But you don't need to know that. You know what I mean?
Yeah. I got out of high school on a sophomore level geometry class.
Yeah. See, I only took basic too. I didn't, basic algebra.
Oh,
That's it. But what'd you call that again?
Calculus.
Calculus. I got to remember that word.
Yeah.
For my next training session. But SRH,
Or might even be trig.
Yeah, that might even be trigonometry.
Yeah,
actually,
it could be.
At that level, that might even be trigonometry.
Okay. Storm motion is removed from the calculation. All right. So again, this is where movement and the spin. Where we're going to get. We got to get lift, and that's what's going to help us with the lift. Now this is a neat one.
Yeah.
And this is, you could find this on there too, because it'll show you the 3. Matter of fact, this right here, I have to give credit to the Midwest Chicago Storm Chasers. His name, let's see.
And Lucio, Danny.
No, not them. No, Chicago Midwest.
Okay. Yeah, those are. That's
I'm trying to
ISC,
think what his name is. But now I'm embarrassed because I forgot. I should know. It's Curtis.
Curtis.
He's pretty good.
Yeah.
I follow him on Facebook, so he knows how to read. He's pretty good.
Yeah.
But what he put on here, this is an area, the target area. You remember, see Illinois right there? Kentucky. We got Tennessee and Missouri. Okay, now we have on the left 925 millibar. Okay, so figure that's 1,000 is ground level.
Yeah.
So we're starting low at 925. Now we're going up to 850 up in the atmosphere millibars, and then we're going to 500 millibars.
Yeah.
Do you see the difference in the wind direction? What's happening?
Yeah.
At the surface, it's coming out of the south. Almost out of the south. Now it's switching. You go up to not to the mid yet, but halfway between there and mid level. Now we got what, south, east, west.
Yeah.
And then
so the fan, the air, the little. It doesn't go. You don't read those from top to bottom. You read them from bottom to top.
Right.
Straight to curve, not curve to straight.
Right. Exactly. So I'm not using my arrow, but you see this right here?
Yeah.
That's the direct. It's the wind's going this way.
It's going.
So
north.
it points right. It's going almost north.
Okay.
Right.
Yeah, north to northeast, and then almost straight east.
You see how we're getting spin now?
Yeah.
Okay, now we're getting shear. That's what they call shear. Now the 500 millibar, that's considered mid-level. Like when we're looking at those tall cumulus clouds and stuff.
Yeah.
Matter of fact, you'll learn the next thing is called the lifting index, which we'll talk about the next lesson. Lifting index is they measure it from 500 to the ground to see how much lift it is, and there's a calculation to tell you how much shear we got. Vertical shear.
Yeah.
And that's what we want. We need vertical shear.
I taught my kids about cumulus cloud last week.
Oh yeah. Val did a little bit of a weather thing for her first graders last week.
What's that?
Val taught her first graders a little bit of weather last week.
Oh, awesome. Yeah,
we talked about cumulus. We talked about clouds.
Oh, that's awesome. That's what I should. I might have one on cloud formation and stuff too, because that's interesting too.
We don't go in that much detail.
No,
we just talk about what they look like.
Yeah, but I mean that's the thing. Even for us, people, cumulus nimbus clouds.
Yeah.
We just talk about the main types. We talk about cumulus, cirrus, cumulibus, how do you pronounce that one, and then stratus.
Stratus, yeah.
Yeah, they're first graders, Terry.
No.
We don't know much.
Hey, that's a good start. People can't answer that. I'm being honest with you. Right now, I can go and ask people the different and they can't answer it.
True.
And I'm talking about big college graduate. You know what I mean?
Yeah.
But you've learned it.
Mm-hmm.
from a teacher.